Atoms and molecules can interact with each other to form substances. These substances can behave in three different main ways. We call these three main ways phases. There are three types of phases: solid, liquid, and gas. Solid substances are very densely packed together and compact. They're very rigid, meaning that all of the molecules or atoms stay in one place and don't move. Liquid substances are a little less densely packed. The atoms are close together, but not packed very tightly. Liquids are not rigid, so they have no fixed shape. This allows liquids to flow. Substances that are gases have a very low density. The atoms are far apart and very disorganized, and gases have no fixed shape. Think of water. The most common form of water, H2O, as we see it, is liquid water. We see water behave like a liquid all the time. If we put water in a cup, it will take the shape of that cup. If we then put that water in a bowl, it will become the shape of that bowl. Water, in its liquid form, can change to be a solid, which we call ice, or a gas, in what we call water vapor. We see water's state change all the time. When we put water in the freezer and cool it, it goes from a liquid to a solid. We call this phase change cooling and freezing. In order to freeze water, water needs to be at 0 degrees Celsius, which is 32 degrees Fahrenheit. We call this point where liquid water freezes the water's freezing point. When you are cooking, you usually heat water until it becomes to a boil. When water comes to a boil, it reaches what we call its boiling point, where water goes from a liquid to a gas. That's why you see steam whenever you heat up water. And water reaches this boiling point at 100 degrees Celsius. The main takeaway here is that a substance can change its phase and it can become solid, liquid, or gas. And water's freezing point is 0 degrees Celsius and its boiling point is 100 degrees Celsius. We know in order to survive, we need to inhale oxygen in the air. But oxygen isn't the only molecule in the atmosphere. There are many molecules and gases in the atmosphere. Some of the most important gases are what we call greenhouse gases. Greenhouse gases trap heat into the atmosphere by absorbing all of the heat from the sun's rays. This results in the Earth heating up. With an increase of this greenhouse gas being released in CO2, the Earth's temperature rises. This is the basis of what we call global warming, which leads to climate change. Other than carbon dioxide, there are several other greenhouse gases. These include methane, CH4, nitrous oxide, N2O, ozone, O3, water vapor, H2O, and fluorinated gases, also known as CHFs. These include methane, CH4, nitrous oxide, NO2, ozone, O3, water vapor, which we are just established as H2O, and fluorinated gases, which we call CFCs. What is the difference between soap, water, and lemon in chemistry? Well, in chemistry, soap is known as basic, water is neutral, and lemon is acidic. But what do those words mean? These words are from what we call the pH scale. The pH scale goes from 0, which is the most acidic, to 14, the most basic. Remember how we said that hydrogen, H, was an atom? Well, if we remove an electron from H, we get a cation called H+. Since hydrogen only has one proton and one electron, if we remove an electron, only one proton will remain. This is why H plus is called protons, or hydronium ions. We can measure how much H plus is in a solution, and how much H plus in a solution gives us our pH scale. Acidic substances, like lemons, have high amounts of H plus and low amounts of another molecule called OH, hydroxide. Neutral substances have about as much H plus as OH minus. The ultimate example of a neutral substance is pure water, H2O, which both has H and OH. And again, this is having a pH of about 7. Basic substances, like soap, however, have small amounts of H plus and high amounts of hydroxide, or OH minus.